Hello, and thanks for coming to this another Nargeber 1 production. Today I'm going to teach you how to write compound inequalities. Okay? I'm going to teach you a bunch of things involving compound inequalities. What they are, how to write them, how to graph them, how to write them in interval notation, whether something is a solution to a compound inequality. Okay, so a compound inequality, real quick, is exactly like a compound word that you learned when you were a kid. All right, a compound word, okay, is a word that's made up of two other words. So, for example, sunflower is made up of sun and flower. Okay, that's what a compound inequality is as well. In math, a compound inequality is a statement that combines two inequalities with the word and or the word or. Okay, so one of those two words will be in between your two inequalities. All right, so let's start by learning how to graph a compound inequality. Okay, so to graph a compound inequality, the graph of an and inequality contains the overlap, okay, of the two graphs. So let's see, for example, let's try to graph x is greater than or equal to 3. Now, I know you all know how to graph this, so we're going to put a closed circle on the 3, and we graph to the right. Okay, and then we'll go here in another color, and we'll graph x is less than or equal to 7. So 0, here's 7. We're going to put a closed circle on the 7, and then we're going to graph to the left. All right, now I want you to graph for me these two inequalities on the same number line. They're now joined by the word and. So they both go on the same number line, and we're going to see if we can find their solution. So let's graph x is greater than or equal to 3. So here's 0 on my number line. Here's 3 on my number line. Okay, that would be a closed circle, and we're going to graph to the right. Now let's also look at x is less than or equal to 7. So we would put 7 on our number line. It comes after 3, right? So we put a closed circle on the 7, and we graph to the left. Okay, now what you can see is that in between the 3 and the 7, the two colors overlap, right? There's both purple and blue between the 3 and the 7. That's where your solution is going to be to this inequality. Your solution is going to be here between the 3 and the 7. It's the overlap. It's where the two colors come together. The two shades come together between the 3 and the 7. Okay, that's the example of graphing an and compound inequality. All right, let's try an or. Okay, a compound inequality with the word or, the graph contains both graphs. Okay, both graphs separately. All right, so if I ask you to graph for me x is less than -2, well, that would be an open circle on the -2, and we draw to the left. But if x is greater than or equal to -1, or I'm sorry, 1, not -1, 1, we'd put a closed circle and graph to the right. So to graph x is less than -2 or x is greater than or equal to 1, we're literally going to put both graphs on the same number line. X is less than -2 would look like that to the left, and the x is greater than 1 would look like that to the right. Okay, this is the graph of a compound inequality with the word or in it. All right, the word or. Okay, and this graph should kind of make sense to you because if I tell you, for example, if you're walking down the street and you ask me for directions and I say, well, you can go to the left or you could go to the right, okay, to get to where your destination is. I would never say to you, it doesn't make sense for me to tell you directions and for me to say, you could go to the left or you could go to the left, right? That doesn't make sense. We don't say it that way. You can go one way or you can go the other. So your graph even shows that. You're going to the left or you're going to the right. That's where your solutions are. Your solutions are on both ends of the graph, okay? All right, let's see if we can graph these compound inequalities that are down here. So let's try to graph x is greater than or equal to 2 and x is less than 5. So let's start with the graph with x is greater than or equal to 2. That would be a closed circle on the 2, and we're graphing to the right. And then we'll try the x is less than 5. That would be an open circle on the 5, and we'd be graphing to the left. Okay. Now, if you look, the and graphs, the solution is the overlap. So you can see where the green and the blue curves or lines, I guess, come together. So the solutions are in the middle, in between the 2 and the 5. Okay, that's where your solutions lie. All right, how about the next one? It says x is less than 0. So here's 0. We'd put an open circle and we'd graph it this way. And then we'd have 4. 4 has a closed circle, and we go to the right. Okay, so this is my solution. My solution is you can go one way or you can go the other. You can go to the left or you can go to the right. All right, and the same thing over here. Here's another or inequality. From 4, we would put a closed circle on the 4, graphing to the left, right? X is less than or equal to 4. And 6 would get a closed circle. X is greater than or equal to 6, and we would go to the right. So again, my OR inequality are all of these numbers, okay, that are covered by these arrows as well as 4 and 6 because they are both included with these closed circles. All right? That's how you graph a compound inequality. Okay? All right, so let's see what else we have in store. Let's talk about some more graphs, I guess. All right? Let's try to make some more graphs here real quick. If we have x is less than negative 6, here's negative 6. We put an open circle to the left. Greater than negative 1, we put an open circle and draw to the right. X is greater than. There's your solution. All of these numbers are solutions. Okay? And then here we have x is less than 8. So let's put the 8. We're going to put an open circle and draw to the left. Okay, and then I'll do it in another color just so we can see it. We have x is greater than or equal to negative 1. We would put a closed circle and draw to the right. And the solution, again, is where the overlap is. So here we have both purple and blue in between the negative 1 and the 8. These numbers in green here would be your solutions, like 0, 1/2, 2, 4, 6, okay? And we'll talk about solutions here momentarily. And then finally, we have x is greater than negative 2. So we have negative 2 with an open circle to the right. And x is less than 4. 4 with an open circle to the left. Okay? And what we have is our solutions lie in between. Okay? Our solutions lie in between. All right? So that's how you would graph, okay, a compound inequality. All right, let's see what else we have in store. So now we're going to talk about some solutions of compound inequalities. How do you figure out if something's a solution to a compound inequality? Okay, for and inequalities, the number must satisfy both inequalities. Okay. So let me explain to you what that means. It's actually easy to understand. So if we go to a picnic, right? We go to a picnic and I ask you to bring me back. We're sitting at the table and you go up to the buffet and I say, "Can you please bring me back a hamburger and a hot dog?" Okay? When you come back from the buffet, you should have in your hand two things, right? A hamburger and a hot dog. If you show up with just the hamburger, I'm not going to be too excited about that. If you show up with just the hot dog, I'm not going to be too excited about that. Okay, I put that word "and" in the middle of hamburger and hot dog because I wanted both, right? So the number must satisfy both inequalities for it to be a solution of an "and" inequality. For "or" inequalities, the number must satisfy one of the inequalities. Okay, must satisfy one, well, let's say one or more of the inequalities. Okay, it could satisfy both, but it has to satisfy at least one. All right. Again, same thing. If I ask you to come back and bring me back a hamburger or a hot dog at the picnic, hamburger or a hot dog, as long as you bring me one of them back, a hamburger or a hot dog, I'm okay with that, right? You did what I asked you to do. Okay? So that's what we mean by being a solution to a compound inequality. All right? Let's see what we can do with that. So here's some nice examples. Here's the inequality in letter A. X is greater than -1 and less than 8. Okay? The first question is x equal 5 a solution? Well, it has to work in both. So the first question is 5 greater than -1? Yes, that's good. Okay? Next, is 5 less than 8? Yes. So then it works in both. That's hamburger and a hot dog. So is x equal 5 a solution? Yes, it is. Okay, how about x equals 10? Is x equals 10 a solution? Is 10 greater than -1? Yes. Is 10 less than 8? No. No good. Okay, so is x equal 10 a solution? No. You brought me the hamburger, but you didn't bring me the hot dog. You brought me the hamburger, but not the hot dog. So no, it's not a solution. How about -1? Is -1 greater than -1? No. So is this x equal -1 going to be a solution? No, we're already done. You didn't bring me the hamburger, so I wanted a hamburger and a hot dog. You didn't bring me the hamburger, so you brought me the hot dog. Great, but I wanted the hamburger too. It didn't work in the first one. It doesn't work. Okay? That's for that. It's an and inequality. What if the inequality was an or? All right. Let's take this one. X is less than or equal to -6 or x is greater than 5. I want to know if x equals 1 is the solution. So first things first, is 1 less than or equal to -6? No, it's not. But it's an or. You didn't bring me the hamburger, but if you bring me the hot dog, I'm good with it. So is 1 greater than 5? No, it doesn't work in either one. So is it a solution? No, it's not. How about -6? Is -6 less than or equal to -6? Yeah, it's equal to. All right, so there's a hamburger. Okay, now at this point, you're done. You already brought me the hamburger back. I want a hamburger or a hot dog. You made it work in the first one, so is it a solution? Yes, it is. Okay, does it work in the second one? No, it doesn't. But I don't care. You already made it work in the first one. So it works because of the word or in the middle. And then finally, is x equals 7 a solution? Is 7 less than or equal to -6? No. But is 7 greater than 5? Yes. Okay, so I wanted a hamburger or a hot dog. You brought me the hot dog. Is it a solution? Yes, it is. Okay, it works in the second one. So that's valid. All right, that's how we tell if something's a solution to a compound inequality. Okay, it depends on the word that's in between. All right, if the word and is in between, it's got to work in both inequalities for it to be a solution. If the word or is in between, it only has to work in one of them. I don't care which one, as long as it works in one of them, it's a solution. All right. All right, let's see what else we have in store here. Okay, let's talk about writing compound inequalities, because one of the weird things about writing compound inequalities is that the and inequalities can actually be written together in a single inequality. Okay, and I'm going to show you why momentarily. So let's look over here at this graph. All right, it says x is greater than or equal to 3 and x is less than or equal to 7. Now, we graphed this before, so let's go ahead and graph it, and I'll show you how we can write it with just one inequality. If x is greater than or equal to 3, that's a closed circle, and then greater than goes to the right. And then if we have x is less than or equal to 7, it would be a closed circle up and to the left. So now my solutions are here, right? In between the 3 and the 7. Okay? That's where my solutions lie. So what we want to do, or what we're at least able to do for the and inequalities, is we can write them in one single inequality, and we can actually put the x in the middle. Okay, if you look at this graph, see the solutions? The solutions that we said in green are in between the 3 and the 7. Okay, they're in between the 3 and the 7. So the way we write that is we would write it as 3 is less than or equal to x, which is less than or equal to 7. 3 is the smaller number, 7's the bigger one. Okay, 3 is the smaller, 7's the bigger. All right, now what you can see is, and I'm going to erase it here in a moment so that you can see, okay, these were my two original inequalities, right? X is greater than or equal to 3 and x is less than or equal to 7. Now, if I kind of erase this or just remove it, if I remove this, get rid of this first part here, you can see, there it is. See that? X is less than or equal to 7. That's that inequality right there. Okay? So now let me erase what was here for a minute and put the 3 back. Okay, and now let me come over here. This is way easier to do on a whiteboard than it is on a computer screen. So now if I erase the second half, I erased too much. If I erase that, this second inequality, you can see it says 3 is less than or equal to x. But if I write it from right to left, if I flip it all around, I would get x is greater than or equal to 3. There's your first inequality. Okay, so we're actually writing something that, yeah, okay, it is the same thing as these two inequalities, just written fancy. All right, just written fancy. Okay, how about x is greater than or equal to -1 and x is less than or equal to 5? All right, so we're going to write this as a compound inequality. To do that, x goes in the middle, the smaller number goes first, the bigger number goes second. Okay, this inequality, the bigger inequality, stays the same. So x is less than or equal to 5 stays the same. And this one gets rewritten the other way. So we would write it as -1 less than or equal to x. So we put a less than or equal to sign there. Okay, that's the inequality. Now, the nice part about these inequalities is that they're actually easier to graph. Because what we can do is look at x. X is in between the -1 and the 5, right? So the solutions to this inequality are going to be in between the -1 and the 5. So -1 will get a closed circle, okay, because it's equal to on this end. The 5 gets a closed circle because it's equal to, and the solutions are in between the -1 and the 5. That's where x is. It's in between the two numbers. Okay, here's another one. X is less than 6 and greater than or equal to 1. Okay, so we put x in the middle. The smaller number goes first. The larger number goes last. And now the larger inequality stays the same. So x is less than 6. That stays the same way. And then this would become, if I write it the other way, 1 is less than or equal to x. So we write that. Okay, now my x is in between. Here we go. 1, 6. Okay, closed circle because 1 is equal to. The 6 doesn't have an equal to sign, so it gets an open circle, and my solutions are in between. And then finally, we have x is less than -2, and x is greater than or equal to -5. So we put x in the middle. Smaller number, -5 is smaller than -2, goes first. The larger number, the -2 goes last. The larger inequality stays the same. And then this one gets rewritten the other way. And we have that. So now we have -5 and -2 on the number line. We have a closed circle on the -5 because it's equal to. An open circle on the -2 because it's not equal to. And my solutions will be in between, in the middle. All right. Before we were graphing both of the inequalities and figuring out where the overlap is. But you can see on this that x is in the middle. So the solutions should be in the middle of -5 and -2. It's an easier way to write this inequality. This, you can write it shorter, and it shows somebody where the solutions are. It's literally showing them, hey, the solutions, they're right over there. Okay? All right, let's see what else we have here. Okay, now interval notation. All right, interval notation. Okay, so now we already know the bracket means it's included. Okay, parentheses means it's not included. Infinity always gets parentheses. All right, now what we're going to also introduce is the letter U. The U means union, okay, or. Okay, it means that there's a gap in between the answers, and I'll show you what that means in a minute. All right, let's try. The interval notation on these is actually pretty easy to do, I think. So here we go. Here's x in the middle. All right, so let's start with, let's graph it first. I think that'll help most of you. So let's go -2, 3. -2 gets the closed circle. 3 gets the open circle, not equal to. And the solutions are in between, just like x. So now to write this in interval notation, the solutions start at -2. They stop at 3. -2 gets a bracket because it's a closed circle. The 3 gets a parenthesis because it's an open circle. There's your solution in interval notation. That's it. You're all done. Okay? Let's look at the next one. Let's rewrite this so that the x is on the left. It would be x is greater than or equal to -2. Okay, so let me come down here. I'm going to graph them first. So we have -2, closed circle on the -2, greater than to the right. Less than -5, so -5 gets an open circle, and we graph to the left. Okay, now we need to know our solutions in interval notation. So here we go. If we look at the first graph that we made, or this graph, the one on the far left, it would start at -infinity and stop at -5, right? We'd use a parenthesis on the -infinity, and then we would use a parenthesis on the -5 because it's open. Okay, now you can see there's a space, right? There's a gap. Okay, so what we do is we use the letter U to represent a union, meaning that these two interval notations are joined together on the same graph. So then my second interval notation here will start from -2. It gets a bracket because it's a closed circle, and it runs to +infinity, and it gets a parenthesis. Okay, there is your interval notation. It's a little bit wonky there. There's a lot of stuff, but that's what you need to write. Okay, And let's try this one here. So let's rewrite this so that x is on the left. It would say x is less than negative 3. So let me go graph it here. We have negative 3, an open circle on the negative 3, and we're going to graph to the left. And then we have x is greater than 2. So we're going to put an open circle on the 2, and we're going to graph to the right. Okay. And again, notice your or graphs go in both directions, right? You can go left or you can go right. All right. I wouldn't say go left or go left. They shouldn't point the same way. That doesn't make sense for an or graph. They should point opposite directions. Okay. All right. So let's go and write this in interval notation. So we have negative infinity for the first graph, and then it stops at negative 3. Okay. There's a open circle there, so that's going to be a parenthesis. And then we're going to use the little u to say, okay, there's a separation, but these two are joined together. We're going to go from 2 with an open circle, so a parenthesis, to a positive infinity and another parenthesis. And that's it. You're all done. Okay, there's your answer in interval notation. All right, so the interval notation on these I think are actually a little easier, but I mean, now that you guys have got the hang of it, okay, it goes really quick. All right, let's see if we can write the compound inequality, and then we'll also put it in interval notation. We're going to do a few of these. Okay, I don't think we're going to do the whole page. Let's look at number 1. So number 1, we're going to write the inequality. You can see there's two inequalities. They're going in opposite directions. Opposite directions. So this is an or inequality. All right, let's look at the first one over here. This one says x is less than or equal to 5. We agree? It goes to the left, and there's a closed circle on the 5. The one on the right says x is greater than 7. Right? Open circle to the right. Okay, let's see if we can write this in interval notation now. So in interval notation, we would write negative infinity to 5 for the first one, and put a bracket, then a u for the union from 7 to infinity. Infinity gets a parenthesis. The 7 gets a parenthesis because it's open. Okay? All right, let's try one more of these or inequalities. So same thing here. They point in opposite directions. So this is going to be an or inequality. Okay? So we're going to have for the first one, x is less than, looks like negative 3. It's between the negative 2 and the negative 4. Not equal to because open circle. Or x is greater than or equal to 9. Okay, greater than or equal to 9 because it got the closed circle. All right, so now interval notation. We have negative infinity to negative 3 with an open with a parenthesis for open circle. U with union with bracket 9 to infinity. Okay, with a parenthesis. There's your interval notation. Okay. All right, let's look down at this one, number 5. We're going to try to write this. Now, you can see here the solutions are in between, right? They're in the middle. Okay, so that means my x is going to be in the middle. My two numbers, the smaller number goes on the left, the larger number goes on the right. So what we want to say here is that the x value, these answers, are certainly smaller than 7, right? They're this way. They're smaller than 7, not equal to because it's an open circle. But these x values, if we're going to read from right to left, we're going to read this one from right to left, the second one here. It's going to say, well, we want the numbers, they're bigger than negative 4. Okay, so x is going to be greater than or equal to negative 4 because we're reading from the x side. X is greater than or equal to negative 4. Okay, and now let's put this in interval notation. These are easy to put in interval notation. We start at negative 4. It gets a bracket because it's a closed circle. We stop at 7. It's an open circle, so it gets a parenthesis. That's all done. Okay, let's come up here to number 2. Number 2, same idea. The solutions are in between the two numbers. So x is going to be in the middle of negative 3 and negative 1. Now, if we start on the right here, the numbers are smaller than -1 or equal to, right? Because it's a closed circle. Smaller than or equal to -1. The numbers are bigger than -3. They're greater than -3. So reading from this side back, x is bigger than -3. So in interval notation, you'll have parenthesis -3, comma, -1 with a bracket. Okay, and one more with the ands just to make sure. They're the tougher ones to write. X is in between the answers. My answers are 3 and -10. Okay, we have x is smaller than 3. X is smaller than 3, open circle. And then we have these numbers here are larger than -10. So x is greater than, just greater than, -10, open circle again. So reading from right to left, x is greater than -10. So we have from -10 with a parenthesis, 3 with a parenthesis. Okay, and I think that is it. I can't remember how many slides I put on this. That's it. The red circle means we're all done. Okay, there is a little introduction to writing compound inequalities. All right, thanks for clicking. See you later.